they wanted to talk about visualization listeners, and perhaps we should start there.
Yeah, let's do that. And I think especially the question was more about also the
wave data.
Yeah. So because basically the visualization listener works like this, and then we play some music, and the VU is moving to the music. So this is very all easy to understand, and also you have the octaves, 8 of them, and you can connect the that's the bass and up to treble. So that's pretty straightforward.
But that is sort of the basis, the foundation of VSXu.
Yes, that's why the project even started. So, but we also have wave data, and we have spectrum data, normal and HQ data. And these are really the same nowadays. When we started out, there were 2 different versions, but these contain the same data today.
All right.
And we can start with something simple. We can just use an oscilloscope, which takes this is a float array, by the way.
All right.
So we add this. Yeah. So this is your basic.
Ooh, nice.
Oscilloscope, very, very basic. And you can also connect that. Let's make this less red. It really stings my eyes.
Alright, fair enough.
So here is the FFT. So you have the bass on the left and up to treble. So this is in the frequency domain. So that's what the octaves and the VU are based on. And this is nice. You can use this to feed some random data, some entropy, bring some entropy into your productions. But you can also go in here and pick out values. And let's try that instead. So let's pause the music for now. There, in the maths section, we have something called array and array pick. So it helps to know that these arrays both are 512 positions, so you can access it from 0 to 511. And now we can use our line again and the angle. So now it's fed from 1 bit of the wave data. So let's try the music again. And then you can select which one, but this is getting new data every frame, so it's really not you won't see any difference if you move this over the array. But what you can do, and I will show you a different example here, is you can make some basic visuals with it. So here on the left we have start of the 512 byte array and the middle, and so we are picking 5 values from it, and we're rendering with 1, 2, 3, 4, 5 macros here. And inside these macros you have a float array pick and a textured rectangle. So this just takes the wave data and which value to pick, and the bottom one has the 500. That's close enough to 511, and the middle one is 200 and something. And you get a rather nice effect when you. We can try some other music, perhaps. Yeah, I think you can get a long way with just this. You don't really need the octaves. And we can of course also use this one again, the oscilloscope. You see that they are in sync, basically.
Yeah, right.
It's the same data. Yeah. And what if we, instead of this, we use the spectrum data?
Whoa.
The size is different in values, so that's why. Yeah, not really as nice, but that works too. But let's get back to the wave data for now.
Yeah, that was more of an acid trip or something.
No. Okay. Do you notice that this blob, by the way, maybe we should just show it what it looks like. So we use a texture rectangle. This is what the texture looks like.
Oh, all right.
And it's done by setting the arms to 3 and change the attenuation a bit. So, but when the music is playing, you can notice that since the values also get range from -1 to +1, you get the texture rotated in inverse. Maybe it's hard to see with that low frame rate on the Hangout, but it kind of accidentally adds to this effect. It looks rather nice, actually, for such a simple thing. And then it's just rotated over here. Yeah. I think that's it for that kind of thing.
All right.
Now you know how the wave data can be used.
All right. But might I then ask you, how do you build a simple particle system?
Yeah, that's our main task for today, which this VSXu Live is all about. So let's do that. Of course, we have the section for particle systems, which is quite basic, generators and modifiers. And today we will look at the basic spray emitter first, which is the first one we did, which is still holds up quite good. And then the simple particle systems renderer. And this data type, particle systems, can of course be connected. And then we could render directly to the screen module, but we probably want a camera. So let's add a camera also. And nothing, as usual. We need a texture also. So let's create a texture. It's even called this blob texture, which is used everywhere. It's even called a particle in the module list. So that hints what it is.
All right.
And we should play time also. So this is what the basic spray emitter does, and we can tweak it somewhat. We can change the speed, the size of the particles. You see they grew instantly. We can do rotations, which is not applicable for these. Maybe we will get to that. We can change the color, and we can change how long they live.
Right.
And here you have a lifetime base and a random value. So if we change the random value to 0, each and every particle will live exactly 1.4 seconds right now. But to make a convincing particle system, you probably want at least as much random value as lifetime base, I think.
Okay.
So from an aesthetical point of view, what do you think should be changed here? What looks odd?
That they are in black squares?
Yes. And I think we touched on this in the previous episode, but it's the blend mode that we need. And we just change that one to 1 so that we have saturated addition.
Whoa.
So now you can see that there are quite a few particles in the middle. If you turn that off, you cannot see that. They are covering each other. So that's what that one does.
Right.
And here we have the simple particle system renderer, which also can do quite a few tricks. I'm not sure we can go into all of these, but size lifespan type is rather interesting. Basically, you can create a sequence. You have to set both size and alpha. So the default behavior is like this. It's a linear interpolation from 1 to 0. But we can add points here, so we can say...
And right now you're changing which value?
Yeah, during the lifetime of a particle, you see that they're created in the middle and they travel outwards. And during this time, they will follow this graph here. And this is the alpha value right now, I think it was. Yeah, this is the alpha value. So now they die off pretty quickly. They are still there, but they are invisible because they are transparent.
Yeah, all right.
So by changing this, you can do lots of rather neat tricks. You see what's happening? So now they are most visible when they are 50% into their lifetime. And you even have... let's do the same here. Yeah, the characteristics of the particle system changed immediately. And you have access to sine values as well to make it smoother if you want. And even busier interpolation for the, as this is a standardized data type, the sequencer data type. And you can change color, so you can make flames and stuff by just changing the color. We won't do that now, but you can. And you can also render with point sprites, but that's not for today. So now we have a particle system running. We can add modifiers to it, which does also quite a bit of cool stuff. So let's go to the particle system's modifiers. Which one should we pick? Size noise is nice. Oops. You see?
All right.
Then you can set the strength. So this is used in quite a few visualizations because it looks like glittering falling things. Yeah, what is it called? Confetti, perhaps?
Something like that, I guess.
Yeah, maybe hard to see with the low frame rate.
Yeah, with my frame rate, I more think of a snowstorm, driving a car in the dark.
Right, yeah. We will upload the MPEG-4 with full frame rate, at least 30 FPS. So we have wind. A really easy modifier to use. Just takes a float 3 in. So they are blowing in one direction. And also see. Yeah, that's pretty straightforward, right?
Yeah.
And we have gravity. And now they are drawn towards a point, which we can move. And they are probably moving too much in the wind. Let's turn off the wind entirely, completely. let's tweak this.
So what's the difference between having a wind blowing down and using gravity?
I think we can illustrate that by making the size a bit smaller first. Yeah, now you can see that they are traveling upwards. And then we increase the time so that they are more like orbiting. They live for a longer period. Yeah, you probably don't see it on the stream, but they are orbiting this point down here.
No, I can actually make that out, yeah.
Cool. And I will show you a visual that does this. You can do cool stuff if you combine wind and gravity, and if you move the center of gravity around. Let's see. Yeah. So, there we go. The amount was set to 0. Now we have gravity in all directions.
Oh, that's weird.
So now we can move it around, and the particles are instantly drawn to this point.
It's like a small tornado or something.
Yeah. And now we only have 100 points, I think, but we shouldn't have more when showing what's going on. So that's that, and we also have gravity and floor. I think I made a small demo of this. Yeah, particle systems and gravity. Because this one is harder to tweak. So here is just a floor, and the particles randomly stick to the floor, and some of them are bouncing. And this is just gravity and floor, and what we have done in the floor module is that we have set Y to enabled and bounce to enabled, as you can see. And then we have set refraction to yes, and the refraction amount, so we can try to lower that and see what happens. Converters, float to float 3. Now there's nothing. So if we increase it up to 10, yeah, that's what we had before. So you can make, if you could synchronize that with the emission rate, particles per second, you see now it really died.
Yep.
We need multiplier because that value is too large. 100 and a slider, and there we go. So let's hook an oscillator to this. Which was it? This one? Yeah, looks nice.
Yes, it actually does.
And when you add much more particles, we can... Yeah, this is actually 1,000 particles. I don't think we are using all of them right now, though. Let's add some more.
Whoa.
Yeah. With a different... I think that's our next item on the list today. And that's to talk about the different render, because this one is using an old OpenGL technique, which is quite slow when you... It's fine for 1,000 particles and maybe 2,000 particles, but when you want 10,000 particles, it starts to be too slow.
So you want to use an external renderer?
No, just a different module, which is newer and more optimized.
Oh, all right.
So, renderers, particle systems, X, this one. This one has some drawbacks though, because it needs shaders and it has, I think it has slight issues with not reacting without these being set. Yeah. So here you have to set these values. So let's just do that real quick.
And is that just bad default values, or is there a reason why those are not set
Well,
from the start?
no, no real reason, but you have to
Alright.
configure them anyway because they're defaulting to large blobs, and you probably don't want that anyway.
Oh, alright.
We can play with the red. Yeah, you see they are white when they start, then the red color is disappeared when they die off.
Right.
And real quick, we can look at the shader program. You can modify that, of course. So now the particles should be, yeah, a lot smaller. Maybe that's better for our needs. And how many particles do we have? We have, let's turn on the frame rate counter. We have that many. So let's try 3000. And we should probably increase this one as well. Yeah, seems to be working.
That actually looks quite impressive if you think of how few modules you're actually using.
Yeah, and now we are approaching 10,000 particles, which is good for a lot of effects. So now we are spewing out all of those, hopefully.
And what would you use such a particle system for?
Lots of things.
Like, example?
Fire, waterfall. What else? There is... yeah, when you want, for instance, something burning in a surface and you want the metal... like, I don't know the English word for it, but it looks like yellow flies that emerge when you heat metal, right?
Yeah, right.
So there.
It is apt that you are comparing or mentioning fire as an example, because that effect is quite mesmerizing.
Yeah, let's try to break it.
Always fun. And while you try to make it break, I could mention that we are monitoring the IRC channel for VSXu. And if you have any questions later on, you are welcome to go there and ask them. I will keep an eye on it.
That's great.
We have a shout out and a thanks for the wave and spectrum data in the beginning from Patrick in the IRC channel.
Ah, great.
He liked that.
Good.
You're not really breaking it, but it is interesting.
It looks different. So yeah. And then if you want to venture into shader programming, you can of course do neat effects with the texture and so on. Oh yeah, we can try to mess with the texture a bit. See what happens. Yeah. Anyway, you see here the frame rendering time.
Right?
It's 0.001,
Mm-hmm.
which is 10 times. It means you can do 10 times this many particles. Maybe not really, but when you render 60 frames a second, each frame takes 0.0167 or something, rounded up. So
Okay.
you have quite a bit of GPU left for other effects in this particular example. Yeah, I feel kind of done with this one. Do you?
Yeah, right. Did you mention mesh generator instead of simple generator, or did we skip that point?
No, I don't think so. That's really cool also.
Perhaps we should have a look at that then.
Yeah, we can probably plug that right in. Particle systems and the generators, and because right now this is generated, they emerge from only one point, right? So we can use a mesh instead to add many points for the particles to emerge from. As you can see, you have a mesh in here.
So you randomize the entrance point?
Yeah.
Okay.
Where each particle is created. So let's try. We have some that only generate vertices here. Could be used. Random vertices. Yeah, that's nice for a start. It might break now, but we'll see. We don't have enough particles. We should probably maybe turn off the floor. Yeah, that's better. I had accidentally enabled Z floor, so now you have a proper three-dimensional floor.
Okay.
So that is, let's save this in case something breaks. You never know. Let's add some more particles. This is only 4,000.
Whoa.
So yeah, as you probably guessed, you shouldn't mess with the number of particles during an effect. You should set that beforehand. Then you can also use sequential or random, which is not really, because if you say we have a mesh with 1,000 vertices and we have 1,000 particles, it means it will take the period of the lifetime for the particles on average before the same vertex in the mesh will emit a new particle. So here you can set it to random instead. You cannot really see that in because this one has only 100 vertices, but when you want to use, for instance, if you have created your own mesh in Blender and export and import an object file, you might want to set the random pick type. And here you can also add some randomness to it all and how much it's spreading in each direction.
I can see that this particle cloud is changing character in some ways, but I find it hard to describe exactly how.
Yeah, I guess you have to play with this to really understand.
And that is a recommendation, to get in there and follow your instructions as per this video and play around with the settings yourselves.
Yes, and we will provide the state for this effect as well. I think I saved it here. Let's save number 3, so you have a few versions to look at.
So then people can go and download this state and play around with the values themselves.
Definitely. And this mesh is really useful. You can do lots of cool things with this one. For instance, you can make particles that don't move and they lie on the surface of the mesh and just glitter there. That's also really nice in some cases.
I don't know. Do you think it might be time for something fun?
Maybe, yeah. We have a different use of particle systems. And if you get what this is, great. If you don't, doesn't matter. But it sure is fun.
At least it says it is.
Yeah. So this is how much fun is it? It's 1,000 times fun. Good enough.
So that is actually 1,000 instances of the word fun.
Yeah, it is. And I thought just we should look at how this is done.
Right.
And we can probably recognize, here we have an oscillator, some coloring, and the mesh spray again with some random, that's what we just did, right?
Right. Okay.
And it's the very basic, simple particle system renderer, no fancy stuff, not the more modern one, it's the basic one. And here we have something nice, the render surface color buffer. So what is happening, let's minimize that for now. In this section, we are auto-generating a texture on the fly, which is then used to render each particle. And to illustrate, we can play with how the word fun is rendered.
Oh.
Like this. And you can probably see that it should, yeah, it stretches above the ceiling. Do you see that? If you look near the edges of the screen, because it's too much clutter in the middle. So
yeah,
that
it cuts off there at the top.
Yeah, so that's the limit of the texture. But you can also translate, and you can do anything here. You can draw the dreaded and very much loved colored rectangle. I'm not sure if that helped, but yeah, there you see. Now it's definitely fun.
Or it's a link to fun, perhaps.
Yeah, it's a hyperlinked fun. Except I cannot click on it. So,
words you never thought you would hear. It's a hyperlink to fun.
Yeah. Isn't that fun?
Yes, it is.
So, yeah.
All right.
And what else is happening here? We are probably, we are rotating the camera. So let's stop that. And then you see, this is a 5-minute build of oh yeah, we're using the text module also, which can take a TrueType font, and so we can say something else.
Render to texture.
No fun.
No, okay.
Moo. Yeah. Did we cover this one, render surface color buffer? Maybe we did in the texture episode, I don't know.
I have some vague recollection, but
yeah. Anyway, dynamic textures is really nice. Let's rotate for fun. Oh no, it's moo.
Whoa.
Yeah. So you probably get the idea. Now for something totally not different, or
more of the same, that is.
Yeah, more particle systems. I'm asking you.
Oh, yeah, of course. Obviously, we want more of the same. But I'm feeling a bit sparkly. Can you do something about that?
You mean the what? The sparkly? I'm not
Yeah,
following.
sparkly water, like a lot of perhaps bubbles.
Oh, right. So this is one of the visuals that ship with VSXu 040, and you should probably know that there is a bug which has been fixed and will go out today or any in the coming days when we will release VSXu 0402. It fixes a few other bugs as well. But we'll play with this visual a bit. First, maybe we should see what it does. So we need some music. And let's increase the multiplier slightly.
Oh my god, it's full of stars.
Or very transparent glowing bubbles.
Right. It's that kind of galaxy. I've seen those before.
Yeah. Yeah, you have probably seen this if you have messed around with VSXu. So let's see what it does.
Is this ordinary particles?
No, it's a different kind. Because the mesh renderer can also take a particle system. So here the graphics card is rendering a sphere mesh many times, and the lighting makes it so that it's only lit from one side. I think we can destroy that and see what happens. Should be possible at least. Yeah, maybe not that apparent. Anyway,
No, not quite.
the mesh basic render takes a particle system, and here we are doing two parallel particle systems. So here is one, and here is another one. And the movement of these particles is basically fine-tuned wind and gravity and size noise. That's it. So you can do things like this. It takes some time to tweak to find the sweet spot, but I think this took me 2 or 3 or 4 hours to get right. And I didn't really know what I was going at when I started, so... And here we have 4,000 particles, and also here 4,000 particles, and they're all rendered as spheres. So you can basically render any mesh as a particle system. So the possibilities are quite big if you want to create your own meshes or just use the ones that are provided, auto-generated within VSXu. I tend to use mostly spheres and blobs because I want to focus on the movement of stuff, but you can also create your own. I think there was a test we did with dolphins, 4,000 dolphins or something. Yeah, you can do that. Let's see if we can find some other. Asterix is using particle systems, lots of it, and as you maybe know, you can go into... You cannot resave these, but you can open them and see what's going on inside. Yeah, these missile attack. This is a typical particle system effect. And I think even these... No, not that one. Oh yeah, this is also a particle system, but I was thinking of this one, which is also a mesh-based particle system. So it's rendering meshes.
Well, this is not a blob.
Nope. Let's turn down the effect level slightly. Yep. So this one I really like. He's using a mesh, a moving animated mesh generator, and then probably using wind to get them to move nicely. There's wind and there's gravity also. So yeah.
Alright.
With those 3 modules you can do lots of different things, so just play around and see what you get. After a while you will get the feel of how they operate, and then you can create things like this.
And these are quite, well, it's not really the right word, but safe modules. You actually get almost all the results you get are quite alright. It's not just a narrow band of an okay visualization in the end, but you can tweak them all you want.
Yes.
And that looks good.
Yeah. It looks like a DNA strand, so that's why I call it butterfly DNA. So that's nice. And this is also, you have probably seen, also the same thing, although some other different rendering tricks. Yeah. Did we have anything else left today to go through?
No, actually, I think we've covered most of it.
Maybe we should see if there are some questions or something else to
I
play
haven't really
with.
received any questions yet from the chat. Hello, IRC. Do you have anything to ask? This is the opportunity to take. But actually, I think they are quite satisfied.
Perhaps. Yeah, we have actually only 1 viewer, but most people will view this afterwards.
And we actually answered the question right in the beginning, so that was the request.
Yeah. If you have any other requests and stuff, we will take a look at it next time.
Feel free to get in contact, and of course it is interesting if you have the opportunity to watch us live, then you can participate through the IRC chat room.
Yes. But thanks for watching, regardless, if you're watching it live or afterwards. We hope you had some fun. We did.
We absolutely did.